Good morning, good afternoon, or good evening, depending on where you are in the world. And welcome to this learning experience brought to you by Mayhem by Secure for All. My name is Cody, and welcome back to Techstrong Learning. We've got an exciting presentation ahead, but before we get that ball rolling, I do have a couple of housekeeping notes I'd like to review. First of all, today's session is being recorded. So if you miss any of our discussion, if you'd like to watch at a later time, or if you'd like to share with the rest of your team, you will be receiving an email with a link to access that recording on demand, and you'll be getting that email shortly after we conclude this live session today. If you'd like to engage with us, there are a couple of ways to do so. The first and the easiest option is the chat tab. That chat tab is on the right side of your screen, and if you see that open, I want you to let us know from where in the world you're joining us. If you have any specific questions, we do want you to send those into the Q&A tab. We do have plenty of time set aside for Q&A, so send in your questions as soon as you got them, and we'll try to answer as many as we can today. If you jump over to that handout section, you'll see there is one resource there for you, and there's also a link to our next session that we'll be hosting with Mayhem, so feel free to secure your spot early. And before we close things out today, we are giving away 4 $25 Amazon gift cards. So stick around until the very end to see if you're one of our lucky winners. So today we are thinking like a hacker and safeguarding our digital world. And joining me today for this discussion is Josh Thorgren, VP of Product at Mayhem. So Josh, thank you so much for joining us here at Techstrong Learning. Why don't you take us a little bit into the mind of a hacker?
Hey, thanks, Cody. Really appreciate it. Welcome everyone. Good morning, afternoon, and evening. Thanks for joining. So, let's talk about thinking like a hacker and then applying those learnings to how we deliver better security. I'm going to cover a few things today. So just kind of level set on where we are. Little introduction. Hey, why am I here? Why am I talking about this? I'll talk about some of the problems that I hear when I talk to developers and security leaders across the world. And then we'll talk a little bit about how hackers operate and what we can learn from them. And then we'll save some time at the end for questions as well. Feel free to drop questions in the chat at any point, and we'll get to them towards the end of the session as well. So, let me kick things off. Who am I? I do a couple things. So I lead the product team, developer relations, as well as marketing at For All Secure. We make a platform called Mayhem. Mayhem's a application security platform built by hackers. It's kind of why I'm here talking today. But before I was a marketer, before I was a product leader, I was a developer, and then was a QA engineer, and then was a DevOps engineer, and faced the challenges of how do we get secure, reliable software in front of our customers, in front of our users on a regular basis, and how do we make sure it remains secure, remains reliable, and remain safe from attack. I transitioned career maybe 15 so years ago, and I've been on the marketing product side at companies like Puppet, Twistlock, and Torque, really focused in on how do we accelerate DevSecOps transformation. You can get a hold of me, Josh at forallsecure.com, if you have any questions following up on this. So with that said, hey, that's who I am. It's my nice AI generated picture on the slide. Let's talk a little bit about what the problem is. So, like I mentioned, 15 or so years ago, I was starting to take security reviews and shift those left and turn it into automated scans in the CI/CD pipeline. Well, it wasn't really continuous at that point, but hey, in the software pipeline. That was shifting left. And we've been shifting left for a really long time. Okay, let's take our stack analysis, let's shift it left. Let's take our SCA, let's shift it left. Let's take our SBOM. Okay, let's run that right after we do a commit. Well, for all the shift left, we're still finding an awful lot of things in production. So Invicti did a survey 2 years back, and what they found was that 40% plus of AppSec professionals and about a third of developers, when they're spending time on security issues, they're spending that time on issues that should have been and weren't caught in development. So That doesn't make a lot of sense. Well, we shifted things left. Shouldn't we be catching this earlier? Seems like it. And then you start to think about, okay, well, why might that be? Why aren't we catching things earlier? And that's because of false positives. If you have run any sort of AppSec scan in the past 5 years, you feel this pain. False positives are everywhere. And, contrast, they did a survey, 80% of teams responded, yeah, over 50% of all my results are false positives. Now, that's absolutely insane. So what we're saying is that when we're trying to build and deliver secure applications, reliable digital experiences, 50% of the things that we're asked to go fix and remediate aren't real. And that's not even counting things that are, maybe they're real, but they're not on the attack surface anywhere. Or maybe they're never leveraged in the application itself. It's just an artifact left over from a prior version. We've shifted a lot of interesting things left. And then you think about it like this, well, okay, so we shifted all these security scans, all these security reviews into the world of developers. But if 75% of dev teams say, well, sometimes we skip security because we're KPI'd on pushing software out, that's not really great. The best type of security is security that everyone actually does. And so if folks are skipping checks, it's not really helpful. And I mean, look, let's be honest, 75% of people are admitting to skipping checks to push software out the door. The other 25%, they're probably doing the same thing. I've been there. I've done that. And you have to. As a developer, you need to push things. You need to push features. You need to push fixes. You need to get those out for your customers. So with all the shift left, speed and security, they're really still at odds. So again, talking about like, what is the problem here? Well, you think about what we shifted left with AppSec. So I kind of think about security, and if you've lived in the network security space, IT security space, cloud security space, you think about posture and activity. What are the risks that I'm prone to? And then what's the anomalous behavior that could be a sign of an attack or an exploit? AppSec's largely been the same. You think about something like pen testing, that's really your, hey, let's go do some activity-based security scans. You think about SAST, SCA, even DAST to some degree, these are reliant on pattern recognition, and they're looking for fixed things, and they're trying to understand, hey, what's the risk posture of this application? What's the risk posture of this code? And so when you think about what really shifted left, well, what we shifted left was the posture stuff, the application posture management. We said, okay, let's go check for vulnerabilities. Let's go check for risks. But we didn't actually say, well, which of these risks are exploitable? How might these be exploitable? How could a vulnerability be weaponized and used against me? That's still largely remained the province of usually a pen tester or someone similar who's doing this post-deploy in production. So, okay, we shifted left the noise of the SOC. They said, oh, well, it gets noisy earlier and it's the developer's problem now. So, hey, that's great. We shifted left the posture management, checking for known issues. Well, okay, I've got a list of known vulnerable packages. Let me just say, oh, you're using all of these. 500 new issues, great. But shifting left in and of itself didn't actually do anything to make finding and fixing issues faster. And that's a real problem because we've changed where we start looking for things. And yeah, that does help with how we can fix things before production, but it hasn't really transformed how we do application security. So this is kind of a problem. And again, it's made worse by a few things. Attackers have a number of advantages that exacerbate the challenge that developers and AppSec professionals face every day. The first is defenders don't win awards for blocking 99 attacks. They get called out for letting one through. And that's an unfortunate reality of how cybersecurity has been treated. And like when we first say we need to fix that, cybersecurity professionals are overworked, a lot of times underpaid, and on the hook to continuously protect a growing attack surface. Like, we have to do more to recognize cyber professionals for all the work they put in stopping attacks, and not just always focusing on the security team when something bad happens. Doesn't change the fact, though, that attackers, they only need to be right once. It's the Death Star. Great defenses everywhere, but oh, look at this tiny exhaust port in the middle of a trench. I'm kind of remembering my Star Wars right, I think. It's been a while. So you think about the second piece. One of the reasons that we shifted left was because there weren't a lot of security professionals. And there are, this was a GitHub survey, I think a year ago, there were 570 developers for every cybersecurity professional. So that hasn't really changed. Shifting left was designed to say, hey, okay, let's help all of these developers find and fix security issues. But all we've really done is create a world where more developers, more code, more features, more pushes to production, and fewer cybersecurity professionals to validate, to vet, to help with processes, to help constrain the noise, etc. And then the third piece is, hey, you can do everything right. Hey, look, my SBOM, there's no vulnerable piece of software, anything in what I've built. Third party did penetration testing on my app. It's solid. I released it. And then someone goes out, finds a 0-day in a package you're using, and gets into your systems. And then you and everyone else in the industry is spending time on costly incident response, yelling at your vendors to go patch things, triaging impact, contain breaches. You just can't stay ahead of someone whose sole job is to go find new ways to break things. So on one hand, we've got a lot of noise that developers and AppSec professionals face every day as they're trying to deliver secure software. And on the other hand, we've got these asymmetries that really give attackers an advantage. And so what I want to talk about a little bit is how can we learn from the attackers, and how can we incorporate what the attackers are doing back into how we're developing and how we're shipping software? Because if we live in this world where maybe you can't always be ahead, and if we live in this world where you're overwhelmed with noise, well, we got to cut through the noise, and we've got to learn how to adopt the techniques of the folks who always do have one step ahead. So let's talk about finding 0 days for a second. So how are 0 days found? Well, let's go back to my nice little acronyms. This is I know there are 4 quadrants here. I don't know if anyone's familiar with Gartner. This is not a magic quadrant. It's a sorcerer's segments, we'll call it. But you think about all these different acronyms, all these different types of security scans, security tests that one might do. And a lot of teams, a lot of AppSec teams have 2 or 3 of these things, 4 or 5 of these things, 1 of these things. But there's a whole section of this that no one who's on the offensive side really cares about. You think about, a couple things. You think about Heartbleed, or you think about, the Tesla hack from a few years back. These were penetration testing, fuzz testing, rapid fire AI, ML scale, like, oh, just go create a bunch of test inputs, test cases, and throw it and see what sticks, and go find some new and innovative way to break something. Now, defenders aren't doing anything like that today. Defenders are largely on this, the left side of this chart, looking for known issues, and in most cases, just doing pattern matching. It's not bad, but it doesn't solve any of the problems that you face. So you think about how this really works. Well, how a hacker operates is, hey, what's my attack surface? Let me understand it. And then let me find a way to get in. Okay, what's the underlying vulnerability, and how can I exploit that to gain more access, to spider out across systems? How can I generalize this so it works anywhere with the same underlying vuln, the same vulnerable library, etc. This type of process doesn't exist in how we do shift left testing today. This isn't in your SCA. This isn't in your DAST. This isn't in your IAST. This is something that's largely done only by folks who are looking to break into software. So what's the solution? So this is the part where we start kind of shifting a little bit, because if you think about that graph that I just showed, there are two parts to it. There's looking for patterns and just understanding behavior. And going back to how security works in a lot of other disciplines, endpoint security, cloud security, there's posture. What are the risks that you have? And there's behavior. What's going on? How does something break? How can something be exploited? And that's where we really need to start shifting to from an AppSec perspective as well. So that's why we say think, and test, triage, fix like a hacker. Hey, let's title this. Wow, look at that. These are the same steps that we just went through, except step 3, it's not go cause havoc, it's go fix the issue. Patch the vulnerable library. If you can't remediate, implement a mitigation. But it's about knowing what's on your attack surface, understanding the ways that your application can be breached, and figuring out what underlying vulnerabilities need to be remediated or mitigated in order for you to stay safe from similar attacks. This is a little bit of a shift in mindset, though, because what this means is you're not really focusing on your list of CVEs. You're not really running down and saying, oh, well, hang on, where am I vulnerable? What you're really doing is you're saying, where am I exploitable? How could my application, how could my services be exploited? What are the vulnerabilities that could lend themselves to an actual exploit? What are the vulnerabilities on my attack surface that someone is going to break in with? And I don't know about y'all, but I spend a lot of time working with our engineers on, hey, okay, we have to justify CVE that was found in our SCA report, and we have to say, oh, well, here's why this happens, and here's why it's okay that's actually in this. Like, we as an industry tend to focus on, are you vulnerable? Is there something about your posture that increases risk? And I'm not saying that's wrong. That's an approach. But it's a time-consuming approach. And it's the type of thing where, okay, we've got justification. Hey, this CVE is actually never on the attack surface. The application, never actually calls the library that's in there. Well, we can spend a lot of time fixing that, and that's not going to do anything to improve the actual security of the app. And so we're spending time triaging and fixing things with no net security benefit. So this is why I say test like a hacker, because a hacker, they're not trying to understand, well, what are all the vulnerabilities this service might have? They're trying to find the one way that they can exploit it. They're trying to find, hey, where's that exhaust port on the Death Star? And we need to do that too. And we need to do that while we're building software. Now, there have been a lot of attempts at doing this, I think. And I don't want to say attempts like I'm being dismissive of where we've been. There's been a lot of really good innovation over the years on how to start taking some of these techniques and operationalizing them. But we're in a different world now than we were 5, 10 years ago. You think about something like first generation fuzz testing. Like, okay, let's go generate 1,000 inputs, run, these as 1,000 different tests against the application. Well, what are your inputs? Well, x equals 1, y equals 2. X equals 1, y equals 3. X equals 1, y equals 4. It's not smart. Sure, you're doing a lot of testing, but you're not actually doing anything that is expanding the coverage or is finding net new ways to break things. But things like machine learning, symbolic execution, generative AI, dare I say it, cybersecurity. I did say I do some marketing. That's my cybersecurity marketer coming out. Advances in how we understand application behavior, application architecture, allow doing essentially automated AI-driven pen testing at rapid scale. How do you curate inputs that break applications and APIs? How do you curate and create test cases that are designed to find interesting ways to break things or expose parts of the application that haven't previously been exposed? Those types of compute exist now in a way that they didn't 5 years ago. They're available in a way they weren't 5 years ago. And, yeah, sure, it's more expensive than running a, SCA report, but it's not as expensive as it once was to run ML-driven techniques at scale, to run compute that really goes out and tries to break things like a hacker would at scale. So when I say hey, this is possible now, I think it is. There's open source stuff that is kind of like third, fourth generation fuzz testing. There's commercial products. Hey, that's why I'm here. Shameless plug. But we're really living in a world where we can put the power of compute resources to work, acting like, our buddy hacker who sits right by us and breaks things as soon as we're, doing a build in our pipeline. So what does that mean? In practice, it means a couple things. If you have an SCA report, if you have an SBOM, you don't prioritize that based on the CVSS score. I'm gonna go out and say it. That's not where to start. What you start with is, are these things exploitable? And that looks like two things. That's two questions. One, are there known exploits against this, or was the type of testing I do able to create one? And two, are these things on my attack surface? If they're not on your attack surface, or if they're not exploitable, put them lower. CVSS score, vital, but start with exploitability. Start with, where is this? Is it on my attack surface? That's how you prioritize developer work, because every single exploitable thing you fix is a net positive to your security posture. Fixing a vulnerable thing, you don't know. So the second piece is splitting out how we think about application security. And I think there's been a good movement towards this more holistically in the AppSec market to talk about application security as a holistic thing. It's not, hey, here's a collection of tools. It's understanding the posture and the behavior of your applications together to assess application risk. It's, how can this thing be used against me? How can this thing be used against our application, our architecture, our services? That's how we have to start rethinking application risk and measuring application risk. Because, I've said this a million times. I'm sure a lot of folks on this call have too. Someone comes to you and says, oh, well, it's vulnerable. And you say, well, no, but that one doesn't really apply to us because, and that because is where we get trapped. And so we need a behavior and posture aware way to assess application risk that does that, instead of relying on a developer to always manually explain that every single time. The other thing here is you got to automate testing and triage. And look, everyone's like, automate testing. Of course we automate testing. Yeah, you do. When I talk to our customers today, the number one thing that slows them down, it's not actually the testing piece. It's someone has to go through and triage every single result. And the triaging of results is painful. It is slow, it is manual, and in a lot of cases, it's just, well, these are 10 results of the exact same vulnerability, just presented in slightly different ways, and all of them are false positives. Let me just close them out. And it just weighs. It weighs on the developers. And that all that noise Well, it makes it really easy to start missing things that are real. And it represents a really large burden that security has placed on dev. So you got to automate this. You got to find ways to ingest your data and start letting machines do a triage for you. Also, I'll go out there, like writing test cases. You want to do unit tests, you want to do behavioral tests, automate it. That doesn't require dev cycles as much as it used to. Not saying fully, but if you can automate how you write new unit tests, if you can automate how you write integration tests, if you automate the writing of those, you're going to go a lot further. And so I've talked a lot about like, hey, do these things in your pipeline. But I want to talk a little bit about one other piece, which is kind of goes back to, hey, what really did we shift left? And this is the fourth, like, how do you actually go think about these things and start to put them into practice, which is don't stop once you've shipped. So we talk about looking at application behavior. Well, if we're talking about, hey, well, use fancy AI ML to generate things just like a hacker would and go test your applications, you can keep running that. You can get smarter. Let it build a larger model over time. Continuously test application behavior just like a pen tester would. And hey, you find an anomalous outcome, you find a crash that can be weaponized, okay, pipe that back and say, hey, let's go fix this. You don't have to block pipelines on this. You don't have to block deploys on this, but use the same technology you use during build to continuously test your software while it runs. You're going to go a lot further if you can automate that versus once a year having a pen test company come in and try to find one or two things running down the same playbook they did last year. We shifted left because we were trying to fix things sooner. But nowadays, we don't have to only shift left. It's security. It's at every stage of the life cycle. It's not done when we ship something. And I think, unfortunately, we've kind of broken into jail a little bit and made security well, it's developers' problems because they have to secure everything in the pipeline. Well, no, it's not really how it works. So the same techniques that you use to dynamically test during a build pipeline, do it once you've shipped. It doesn't have to be against your live app. I wouldn't necessarily recommend that, but hey, do it against staging, do it against a test version. So let me kind of pull that all back. What does this actually look like? Because, hey, nice big concepts. Wow. Use the techniques and tools of attackers in your CI/CD. Like that first and foremost. Dynamic testing, behavioral testing. You have to be trying to understand how your application is going to behave and how it's going to break and trying to break it as early as possible. If you're not doing that, you're giving up the ability to be a step ahead. Test cases, automatically generate these as much as possible. Like, don't have your team writing unit tests. Let machines come up with weird, crazy ones that don't make any sense. Let machines come up with ones that are going to expand your code coverage. Create tests, create inputs algorithmically. Don't use dev cycles on it. Attackers aren't going to write a bunch of different tests, write a bunch of different inputs. They're going to let machines do it because they're trying to operate at scale. Do the same thing. Developers only get validated results. And this is one like, look, you can use automation here, you can use machines here, you can use process here, but if a developer is being asked to do feature work, improvement work, bug fixes, just any normal sprint work, and also part of that sprint is go comb through all the SCA results and tell us which ones we need to fix, you're not using that developer's time right. Devs need to get validated results, full stop. If we're asking our devs to go understand the outputs of a security tool, if we're asking our devs to go validate and triage and sort through that 50% plus false positive rate, we're wasting the talent that we have to push new features out, to deliver new experiences to our customers. And then success. And this is another thing, going back to, hey, we need to recognize our cybersecurity professionals more. If you're fixing things where you've proven exploitability, you're actively improving your security posture in a really measurable, meaningful, and demonstrable way. And we really need to start thinking about application security as not a, hey, how do I maintain no critical CVEs as my posture? It's not maintaining a status quo. It's continuously finding and remediating exploitable issues. That turns AppSec into heroes. Everyone who's doing that, well, hey, they're hacking and fixing their own software. And when you're fixing exploitable things, this is something to celebrate, and it's something clearly understood as well. And so it allows us to recognize AppSec professionals, developers involved in this process even more, while at the same time driving improved security outcomes versus maintaining kind of a status quo of, well, we don't have anything critical, so we're probably safe, which it's not secure, but it's the floor, not the ceiling. Let's raise the ceiling. So that's what I got. Hey, here's the problem. Here's what I think we should start doing about it. Here's kind of philosophically where you fit that in, the types of tools and technology to use, and then a little breakdown on like, hey, do these steps, do it in this order to get started. I gotta do it. I gotta do it. I gotta do a little shameless plug. Hey, why am I here? Mayhem, it's a platform that uses a portfolio of fancy algorithms. You can call it generative AI. It builds models of your apps and APIs and their behavior and uses that to try and find new and interesting ways to break them, automatically triages everything, and then pipes through only real results to your devs. Like, look, we're a commercial product that does this. So that's the shameless plug. There are, pieces of what we do. You can cobble together from open source tools. There are other folks out there. I'm not saying we're the only one. I think we're the best, but our goal is to get AppSec out of this noise and start allowing AppSec to make meaningful security improvements on a regular basis without all the hard work of test and triage. So, check us out, mayhem.security. I've talked to everyone for, I think, about 30 minutes now. It's my goal. I told Cody beforehand, I'm aiming for 30, so it's going to be either 25 or 35. So we'll see. But, big thank you, and I'll turn it over to folks for questions.
Awesome. Hey, Josh, I just want to make sure that you can hear me.
Loud and clear.
Perfect. So everyone in our audience, we are now opening up for our formal Q&A. So send in any questions you may have. But for now, we'll just take the ones that we do. So, Josh, do you have any examples of recent cyber attacks?
I mean, check the news. I think everyone, this week is interested in what's going on with WebP. I think the things that I'm hearing a lot about, though, to be honest, aren't as much in the digital sphere. The things that I'm hearing from our customers are largely in the, let's call it IoT adjacent sphere. And, I mentioned earlier, I made an aside to Tesla hack, but the number of different ways that you can break into a smart car or a robot vacuum or a medical device is proliferating, because what we're seeing is there's more and more software being put on these devices, and there's more and more vulnerable libraries and room for error and challenges with testing hardware and testing the software interaction. There's more and more of that. And so, I'm not going to name names or call out anything specifically, but what I'd say is that's what I'm really keeping my eye on and looking at is how the broader IoT industry, smart devices, connected vehicles, whatever you want to call it, how we're starting to respond to cyber attacks there, and how we're starting to, both from a public and private standpoint, provide guidance on how to better the supply chain security and development security on that side. I think those are the types of things that keep me up at night. WebP, the MGM hack, those don't keep me up at night. Those I share around, but at the end of the day, I'm really concerned about the things that we don't interface with software on day to day. Those starting to be breached more and more. I know I dodged that one. I hate naming names a ton. There are lots out there.
Understood. So, all right, we'll move on to our next one. Josh, could you please share what is the main attack vectors Mayhem can utilize?
Yeah. So this is a I looking at the question, you give a couple examples like, hey, for REST API, Graph API, or GraphQL, Mayhem essentially works. I'm going to try and balance not going into minute technical detail with giving you a crisp answer on this one. If Mayhem's testing an API, it's going to be making calls to your endpoints. It's going to be taking a look at your spec and finding out what gaps there might be and using those to create new ways to combine payloads and endpoints and calls. There's a lot of work that it does on the back end to be smart about the ways that it's trying to break things. But when we're talking about API, the attack vector is hitting your API and understanding if the behavior opens up the door to do something that it shouldn't be doing. There's not necessarily hey, we're breaking this down by different attack vectors. It's how do we break it? If we're looking at, just your application, not an API itself, it's the same thing. We're not doing pattern recognition. We're not trying to match any, particular set of, hey, oh, look, this library is vulnerable. It's really about taking your app, packaging it up and allowing us to kind of sandbox and run and test and breaking it in that environment. And so there's not, hey, look, it checks these attack vectors, but it doesn't check these. It's how can we find interesting ways to break things while running it within our sort of pseudo sandbox environment. I say pseudo sandbox because if I say sandbox, it's not entirely accurate. If I say not sandbox, not entirely accurate. So anyway, that's the technical detail I won't go into, but we don't tend to think about our tests as attack vector oriented. It's mainly, hey, what are the ways that someone interfaces with this app or this API? Let's use those and let's go break things. We have customers like in the gaming industry, and so Mayhem ends up simulating what a user on a mobile device does that then gets sent to a server via an API because the mobile device is really the client shell. We have folks, just on the standard SaaS software side, Mayhem tends to look a lot more like a user of a website. And it's just nature of how Mayhem learns about different apps and APIs. Happy to do a follow-up on that and answer. So,
yeah, if who asked that question? Looks like participant 378. If you have any additional details to add to the question or a second part, please let us know and we'll be sure to address it. So looking at our next question, it looks like it's tough to find those, quote, diamonds in the rough that have the gamer or challenge mindset to hire out to work out the solutions for CVEs and attack vectors. You have a secret sauce for that or tricks of the trade?
I mean, I wish, and I say that as someone who's been in, DevSecOps or cybersecurity product or marketing for, 15 years. Like those types of folks are really valuable from, a security researcher perspective too. I think I haven't found any sort of, oh, here's what that profile is. But what I'll tell you is one of the challenges that when I talk to a lot of folks who do have that mindset to say, okay, this is a bug, but is it a vulnerability? Can I exploit it? One of the things I hear from a lot of those folks is like, look, I would love it if I didn't have to do all the work to find the underlying issue in the first place or to triage and sort through. They get annoyed by the types of noise that their testing does. They just want to go, okay, how do I weaponize this? How do I exploit this? And conversely, hey, what things need to be patched? And so, one of the guiding philosophies behind something like Mayhem is, hey, how do we take away a lot of the work to say like, hey, this is definitely exploitable and needs to be fixed. We're not actually going in and weaponizing anything, but we're giving the folks who do want to go that extra step as much as possible to either, go patch, go remediate, go mitigate. I think it's a lot of times for me, it's been less about finding the right person or the right set of skills and more about making sure that the work that they have to do isn't boring and repetitive. And unfortunately, a lot of times to get to the point where they're even like working out the solutions, there's a lot of boring and repetitive work. And so how do you split that up becomes a little more interesting. And hey, how do you structure your teams? Is that like junior, senior, et cetera? A lot of different approaches to it. I think that's the solve I've typically seen and done successfully though.
Okay, that makes a whole lot of sense, and that's kind of falls into the stopping the false positives and really figuring out where the issues lie to begin with. So that totally makes sense. It looks like we did get a follow-up question from participant 378, and
Yeah.
they ask, when you mention about self-learning algorithms, does Mayhem use its own engine, or do you use third-party AI resources?
Yeah. So Mayhem has our own proprietary engine that combines a number of different techniques, and the way it works is based on how you've written your API. Hey, is it REST? Are you trying to do GraphQL? What gRPC? What are you doing with that? Or based on your application architecture, Mayhem makes some default assumptions about ways things can break. But then from there, Mayhem builds a model that is unique to that particular thing under test, library, application, API, and that model then informs how Mayhem learns over time. And so it's not, it's no third party, it's all Mayhem. We leverage some like open source stuff just to execute testing, but that's largely just the execution, not the intelligence. The other piece, though, just about like AI and data sets is Mayhem doesn't cross train. So, your apps aren't building a model that learned from each other. It's only one API or one set of things under test. So if you're testing an app and API together, hey, how do we consolidate that? But it doesn't cross train. So there's not, we're not building like some, hey, crazy secret model of application behavior across all our customers or anything like that. I know you didn't ask that one, but anytime people are asking about like first party, third party stuff, I'm like, hey, let me make this one clear.
For sure. So it looks like we do have one question left, and it just addresses what are some common misconceptions about proactive security and what are the best ways to address them?
So like, I don't know. I tend to think about this as like, a lot of things I talk about here. I talk to folks who've been in the industry a long time. And they're like, I mean, what you're talking about is pen testing. Oh, what you're talking about is fuzz testing. Oh, what you're talking about, like, and it's this idea that either these things are really manual or automated and really dumb. And I think one of the biggest misconceptions that I see is, and again, honestly, I think this is a weird thing because I go look at how cloud security companies or endpoint security companies are evolving. And it's all about, hey, using AI to triage and detect and understand anomalous behavior and build models of what your endpoint should look like. And we're not really doing that in AppSec. We really haven't done that. We've got faster static scans, but we don't have smarter behavioral scans or faster behavioral scans. And so I think one of the biggest misconceptions is that this is either hard or manual. And really, our company's thesis and my thesis in general is no, it's not. That's the biggest one.
Awesome. We did actually receive another question. So to kind of look towards the future, are there any emerging cybersecurity trends or technologies that we should be aware of to stay ahead of potential threats? So what do you think is coming down the pipeline?
There's been a lot of discussion, I think, in the media about the security risks of AI, and a lot of that has been focused around like what threat is posed by essentially breaking into and exploiting a AI trained model or the model itself. And I'm not that worried about that. What I'm worried about is, I go back to my own like DevOps journey. 20 years ago, 25 years ago, maybe, if we wanted to put software up and running somewhere, someone had to copy some files over to a server, and someone had to spin up the server, and someone had to configure the server and log in for updates. And, now I could probably multitask spinning up a Kubernetes environment while giving this webinar. I'm not going to try, but things have gotten a lot easier. And how much Kubernetes do I have to know? Not that much. The barrier to entry for a lot of ops, DevOps, IT, even security, like the barrier to entry has gotten lower over time, which is a really good thing. It's a really good thing. The thing that scares me and the thing that I think we all need to be aware of is AI lowers the barrier to entry for everyone. And we talk about all the different ways AI can help automate and accelerate different parts of everyone's 9-to-5 job. But how is someone who's trying to break into systems day to day, how are they using AI? What are they automating? What are they accelerating with it? That's the trend that worries me the most, because there's not a lot of information out there about that. And security is already overworked. Security is already overwhelmed with noise. Things that allow attackers to generate more signals, more exploits faster, that's what worries me the most. And that's what I think that we all need to, from an industry perspective, just be really on top of, is understanding what are the ways in which we're going to see increased speed and scale of attacks. It's a good question.
Yeah, it absolutely is. It's a whole lot of unknowns and a whole lot of ways it could go.
Computers were a mistake. I'll say it.
Well, that cat's out of the bag. Josh, we don't have any more questions today. I really do appreciate you taking the time to join us here on Techstrong Learning. I know my mind is just boggling trying to take in all of this, but is there anything that you'd like to leave our audience with before we close out? Maybe something with a positive note. We've been talking about attacks for a little too long. What do we got going on that's coming down the pipe that's good?
A lot. I don't want to be all doom and gloom, and you're right. Let's end on a positive note. The good news is this. We're like, over the past 10, 15 years, we've really created this world where cybersecurity, development, engineering, these are much easier to step into for anyone. And what that has done is we're creating a much more digitally literate world. And that's giving us the ability to start to all collectively work together on like solving these big challenges. I think so much of where like a lot of the early like cyber threats and challenges came from was there was a lot of knowledge being gatekept. And, oh, well, here's how things work, but you got to go ask the sysadmin. Oh, well, sysadmin knows. And now it's, hey, let's express configuration as code, security as code, policy as code, and really opening up the ability for folks to be involved at all steps of the process and really working to translate down the technical ins and outs. Hey, how does Kubernetes work? I don't know. It's got some pods. Like things like that have really helped us build a stronger digital foundation. I think that going back to that, hey, 570 developers for every one security professional, advances like that start to blur the lines so that we're all DevSecOps operators and engineers at all times. And I think that's a really net positive for the industry and the world. So I'm encouraged by that. I continue to be encouraged by that. My goal is to help folks who are on that journey, like spend less time on the dumb, boring work that machines should be doing for them. So I think we're getting there.
Awesome. Well, I look forward to it. I'm ready to. Security is the name of the game, and we've really got to figure out how to make it part of the process at the very beginning and really implement it at every stage of the process.
Secure by design. Love it. Hey, thanks so much. Thanks, everyone. Thank you, Cody.
Of course. Josh, thank you so much for joining us today. I would just like to remind our audience today that we have recorded today's session. If you'd like to rewatch, if you joined us late, or if you'd like to share with your team or your friends, you will be receiving a copy via email shortly after we conclude here. You can also find it living on the DevOps website. Just visit devops.com/webinars and be sure to look in the on-demand section. The 4 winners of our $25 Amazon gift card drawing, they are Victor O, Karsten R, Louise F, and Henry M. So to our 4 winners, I'll be reaching out to you shortly to get gift cards distributed to you. If you don't happen to see the email, check your spam folder just in case it happens to be filtered out. I'd like to thank Mayhem for sponsoring our program today. And to our audience, thank you so much for your questions, your participation today. At the top of the chat, there is a link to our survey, or if you just hang out with us until we close out, that survey will pop up on your screen. We do hope to see everyone at a future Techstrong learning experience, and have a great rest of your day. Josh, thank you so much.
All right, thanks again. Bye all.